Okay. Now we will continue. Now we will continue with this the next lecture. It is on the logic gates. I will share the slides on the logic gates. So this is actually only about 7 slides. So it will be very fast. Right? So I record already, right? Okay. Maybe it's about 7 slides. Then I'm going to share the slides now. So you can see the slide. Lecture 7, Digital Fundamentals, Applied Digital Fundamentals, Chapter 3 on logic gates. Okay. Logic gates. This is very simple. Very simple slides. What is gate? Gates is actually used to describe a circuit that perform a basic logic function. Okay. Basic logic operation. So the gates that we are talking about is the inverter, AND gate, OR gate, NAND gate, NOR gate, exclusive OR, and exclusive NOR. So we have 2, 4, 6, 7 gates, and we have 7 slides for this whole chapter. Okay, inverter basically that to invert from 0 to 1, 1 to 0, and it's actually to end between 2 bits, 0 and 1, 1 and 0, 0 and 0, 1 and 1. So what's the result? Or is actually to add 2 bits, 1 1, 1 0, 0 1, 0 0. NAND and NAND is actually AND plus with the inverter. NOR is a OR with an inverter. Exclusive OR, exclusive NOR, those are a bit more complex. So this is an inverter. The inverter performs the Boolean NOT operation. What does it mean by NOT? If it's A, then the answer is not A. So it's represented by this symbol, a triangle with a dot or a round, a circle at the end. Okay, so it means this circle means not. So A, if the input is A, then the output X is A bar. So A not, not A. So the output is A bar. So the truth table for this NOT gate or inverter is that if the input is 0 and the output A bar is 1, it's the inverse of that. If the input is 1, so the output A bar is 0. So it's invert. If it's positive, it becomes negative. If it's negative, becomes positive. So remember in the op-amp, this is an inverter. So that op-amp that we learn, inverter, actually to implement this kind of gates, logic. So the Boolean expression for an inverter is A is equal to A bar. When you see a bar here, basically that you invert whatever value of A. If A is 0, then A bar is 1. If A is 1, then A bar is 0. So this bar means that you invert. So how do you use this inverter? It's actually for the ones complement. Remember the ones complement that you invert from 1 to 0, 0 to 1? So you use inverter to implement the ones complement circuits. And that circuits, actually you use the op-amp that we learned in chapter 4. So that is how it relates between the analog circuits with the digital electronics. So let's say that you have an input like this, the blue one, low, high, low, and high. So therefore, an inverter or NOT operation is that when it's low, the output, if the input is low, the output is high. When the input is high, the output is low. When the input is low, the output is high, and the input is high, the output is low. So this is actually the functions, the timing diagram, the waveform for the output if the input is like this. So in this digital electronics, this is actually important because in the exams, we will ask you to do the timing diagram of the circuits. Any question on inverter? Simple.
No, sir.
The next one is AND gate. The AND gate produce a high output when all the inputs are high. Otherwise, the output is low. So what is this like? This is actually like a multiplication. This is really when you implement the multiplication, bit multiplication. So AND gate, basically that what you need to AND two or more inputs. This one is a two input example, A and B, and the output is X. So what is X when you have A and B? It depends on what are the inputs like. If it's both are 0, A is 0, B is 0, the output is 0. If A is 0 and B is 1, the output is 0. Because the rule is that you need both to be high, both to be 1 in order to have a output of 1 or high. So A is 1, B is 0, it's also 0. A is 1, B is 1, then the output is 1. Okay? So let's say that you have this signal for A and B. Low, high, low, high, high, low. And B is low, high, 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 low, low. So the output is low. 1 and 1 is, according to the truth table, is 1. So high. Low and high, so the output is low. High and high, the output is high. High and low, the output is low. Low, low, the output is low. So this is the timing diagram for this example, right? So this is the AND gate. AND gate is similar to the multiplication. So when 1 and 1, then you get the output of 1 of high. Any question on AND gate? Simple. If not, we go to this. So this is actually for AND gate of more than 2 inputs. The AND operation is usually shown as with a dot between the variable, but it may be implied. So if it's not, if you don't have a dot also, it means AND here. X is equal to A dot B or X is equal to AB. So it can be written in both ways. A dot B or A equal to AB. Normally, I prefer this. This is how I write actually. I rarely use this. I normally use this. For example, this is for 3 inputs. So A, B, C. So therefore, X is usually A, B, C or A dot B dot C. And this is actually for the 4 inputs. A, B, C, D. X is A, B, C, D or A dot B dot C dot D. So this is actually the representation of the Boolean for the AND gate of 3 gates and 3 inputs and 4 inputs. So the Boolean multiplication is the same as the AND function. 0.0 is 0, 0.1 is 0, 1.0 is 0, 1.1 is 1. So AND actually is implementing the Boolean multiplication or bits multiplication. Right? Bising ke dengan apa ni lori sampah luar rumah saya?
Tak ada.
Oh, tak dengar kot. Okay. Memang
Tak
bising.
dengar pun, sir.
Okay. So now, this is an example of the application of AND gates. A seatbelt alarm system. So a seatbelt alarm system, let's say that this is the truth tables of the alarm system. You need to have all this A, B, and C to be high. When the ignition is on, when the unseat is unbuckled, and when the timer is high, therefore the alarm, the seatbelt alarm is on. So that is the condition. So this is the design. So basically that you have the ignition must be on, and the seatbelt is unbuckled, and the timer is on for 30 seconds, then the alarm for seatbelt alarm is on. If not, or off. So this is an example of the implementation of the logic using the AND gates. Right? Clear?
Yes, sir.
Yes,
Faham?
sir.
Yes, sir. Faham.
Okay. Now, the third gate is OR gate. The OR gate produces a high output if any input is high. If all inputs are low, then the output is low. So this looks like what? This looks like an AND, right?
Yep.
Right?
Oh, yeah.
0 and 0 is 0. So anything, anyone is 1 is 1.
One.
Okay? When both are 1 is 1.
One.
So the symbol is like this. You have this curve. If you compare with the AND gate, you have a straight line, right? But for the OR gate, it's like this. A and B, A or B is X. So this is the truth table. So the timing diagram, let's say you have 10110 and B is 11100. So therefore the output is that 11 is 1, 01 is 1, 11 is 1, 10 is 1, 00 is 0. The timing diagram basically that it triggers when it start here, when it start the changes. Okay? When it's changed, then the output will change.
Change.
Yeah, so it is at the trigger, whether here, when this changes, right? Here, right? So that is all. Clear?
Clear, sir.
Simple. So this
Yes, sir.
the OR operation is shown with a plus sign between the variables. Thus, the OR operation is written as this. X is equal to A plus B. A or B. That's what A or B. X is to A or B. So if you have 3 inputs OR gate, so the X is usually A plus B plus C, or A or B or C. If it's 4 inputs, then A or B or C or D, or A plus B plus C plus D. So Boolean addition is the same as the OR function. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. So 1 plus 1 is not 1, 0. It's 1 plus 1 is 1 in Boolean addition or in bits addition. This is an example of OR gate, an intrusion detection and alarm system. So let's say you have this 4, you have 2 windows and 1 door. So as long as any one is open,
It
as,
triggered
will trigger the alarm. It's
alarm.
anyone. So basically that one you connect to the window, another one you connect to another window, another one you connect to the door. So
Door.
either one is high, then you get an alarm. So as long as the window and doors are secured, the switch are closed. When one of the windows or doors is open, a high is produced on that input to the OR gate, and the gate output goes high. It then activates and latches on the alarm circuit to warn the intrusion. So this is the logic gate, the truth table for this. 0, 0, 0, basically they are all closed, the output is 0. If the door is open, then it has an alarm. If it's a window B is open, it's an alarm. If both window B and door is open, then it's an alarm. If only window C open, is alarm. If window C and the door, window A and the door is alarm. Or this is the truth table for that. Okay. NAND gate. This is not AND. NAND is from the not AND. What is the symbol? It's like this. AND gate with a not. The NAND gate produce a low output when all inputs are high. Otherwise, the output is low. If you look at that, this truth table is basically the inverse, the invert of the AND gate, right? The AND gate was 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 1. So when you put a NOT, then it becomes opposite. 0 becomes 1, 0 becomes 1, 0 becomes 1, and 1 becomes 0. So this is the truth table for the NAND gate. And NAND gate is actually that you AND first, then you NOT. So A, B, okay, A and B, then NOT. So the Boolean expression for the output of two input NAND gate is A is equal to X is equal to A not B, A dot B bar, or also can be written A B bar. So you do the A B first, or A dot B first, then you take a NOT. So that is the process. If you have this long bar like this, cover both A and B. So you do the A B first, then you NOT. So from here, actually, you can see the process how you do that. You do the A B first, the N first, then you NOT. So this is the example of the timing diagram for NAND gate. So let's say you have this A, 1 0 1 0 1 0 1 0 1 0, and B is 1 1 1 0 0 0 1 1 1 0. So X, the output is that when you have both high, 1 1 is low. When 1 is high and 1 is low, is high.
High.
When both are high, is low. And here, low and low is high, high and low is high, low and low is high. So high and high is low, low and high is high, high and high is low, low and low is high. So A and B are both high during this 4 times interval. Therefore, X is low. So this is the timing diagram for two input NAND gate. NOR gate. The term NOR is a contraction of not or. So it's similar to NAND gate, that in NOR gate, you OR first, then you NOT. So if you take, remember the NOR gate is 0 0 is 0, 0 1 is 1, 1 0 is 1, 1 1 is 1. So therefore, a NOT gate, you inverse. You invert the output. 0 becomes 1, 1 becomes 0, 1 becomes 0, 1 becomes 0. So this is the truth table for NOR gates. So the Boolean expression for the output of two input NOR gate is like this. X is equal to A or B and bar, not. So you do the A or B first, then you not. You don't do A not, B not, then you OR. No. You do the OR first, then you not. So this is the timing diagram for the NOR gate. So let's say you have 1, 0, 0, 0, 1, 0, and B is 0, 0, 1, 0, 0, 0. So when you have any one of them, A or B is high, then it's 0. So here, okay. So the answer is 0, 1, 0, 1, 0, 1. Exclusive OR. Exclusive OR gates produce a high output only when both inputs are at the opposite logic level. So the symbol is actually, you have this curved line here. So this is actually the XOR gate symbol, A and B, and X is the output. So it says that when you have opposite levels, A and B has opposite levels, therefore the output is high. If A and B has the same level, the output is low. So if it's A is 0, B is also 0, therefore X is 0. A is 0, B is 1. So we see there is a difference between A and B, then it's high, 1. A1, B0, so X is 1. A1, B1 is the same level, then it's 0. So this is the truth table. So the Boolean expression for the output of two input XOR gate is, you can write like this. X is equal to A bar B plus A B bar. Or X is equal to A XOR B. So XOR sign is the plus in the circle. So this is the expression, but actually this is the operation, is like this. A bar B plus A B bar. Okay. Actually,
Okay, sir.
okay, clear.
Clear, sir.
Exclusive NOR. Exclusive NOR. Actually, you take the XOR and you not.
Dia macam NAND je, sir.
Eh?
Dia macam NAND je.
Tengoklah dulu.
Oh, okay, sir.
NAND lain. Ni exclusive OR.
Dia lawan eksklusif lah tadi
Dia lawan exclusive OR. Dia
Oh.
exclusive NOR.
Ya.
Okay.
Kalau sama, okay.
Okay. So basically that the Boolean, the truth table is that 0, 0 is 1. Previously was 0, 0 is 0, right? 0, 1 was 1. 1, 0 was 1. 1, 1 was 0. So now with a not, then it reverse. It becomes 1, 0, 0, 1. So this is the truth table for XOR, XNOR. So the Boolean expression for the output of the two input XNOR gate is as this. X is equal to A, XNOR B. So XNOR symbol is a dot in a circle. The expression is that X is usually A bar B bar plus A B. So you remember the A bar B bar. So you not first A, then you not B, then you N. Difference then A bar, then different than A B bar. So here it is. You see, A bar B bar. If you compare with this one is different. A, B, bar. If this one, NAND gate, you do the AND first, then you NOT. Whereas this one, you NOT A, NOT B, then you AND. Plus A and B. So this you have to be very careful when reading this. A B bar is different than A bar B bar. So this is the timing diagram for exclusive NOR. So it becomes 1 when you have the here. When X NOR, it becomes 1 when you have the it becomes 0 when you have a different opposite level. It becomes 1 when you have a same level. So this is XOR, and XNOR is the reverse of the XOR, right? So this is actually the representation of the XNOR. This gate. This is X. This is NOR. This is NOR. This is XOR, like that. This is XNOR. Okay. This is actually this one. This part is XOR. This is XNOR. So this is give this. This output is give this timing diagram, and this output is give this timing diagram. Okay? Don't be confused. So this is XOR. This is XNOR. You see this. The difference is this dot, this circle, small circle here. XOR, XNOR, XOR, XNOR. Okay. In summary, these are the distinct shape symbols and truth table for various logic gates. For this example, we use a 2 input. This is AND. So this is the truth table. This is OR symbol. This is the truth table. This is NAND. NAND is basically the NOTs of AND. This is the truth table. This is negative OR. You see this? That you OR first. That you NOT first, then you OR. So you NOT first, then you OR. So this is the truth table. So if it's 0, then this becomes 1. 0 becomes 1. So once or 1 is 1. 0 and 1 basically become 1, 0. So it becomes 1. 1, 0 becomes 0, 1. Become output 1. 1, 1. 1 becomes 0. 1 becomes 0. So 0, 0 becomes 0. So this is negative OR. This is the inverter. This is a NOR. This is a negative AND. So you compare with this. NAND is like this. Negative AND is like this. Negative AND basically you NOT first, then you AND. NAND is you AND first, then you NOT. This NOR and negative OR is, you see this. So the truth table also different. So this is exclusive OR and the exclusive NOR. So just reverse the output, the NOT the output for the exclusive OR. So that is the end of the logic gates lecture. Any question? Yes? Any question? Clear?
Clear, sir.
So next lecture will be, we are using these logic gates to do the Boolean algebra. Boolean algebra is very is a bit difficult.
Oh no, sir. Yeah.
Boolean algebra is difficult. It's a bit difficult because you have to a few rules, De Morgan's rule and whatnot that you have to remember. Hmm? Okay.
Sir,
Yes.
whatever contoh A bar, maksudnya dia akan jadi not sir. A
Inverse.
bar,
A bar basically not A.
not A. Kalau A, B bar,
A B bar panjang.
bar panjang.
So basically not A B. Whatever result of A B, you inverse.
Oh, okay.
Okay, like this. Okay. We take this. Okay. This and this. Okay. This is actually A B not A B bar. This one is actually A bar B bar. Okay. This is here A B bar. This one is A bar B bar. This one A bar plus B bar. This one is A plus B bar. Different.
Oh.
Okay.
Okay, sir.
So maybe I will add here lah. That is, what does it mean? I will add the expression. So that you are clear. I will add. Okay.
Okay, sir.
Any question? No question.
No.
Yes, sir.
No question.
Sir.
No question. Then I will. Okay. Okay. So no question,
No,
So how many attend so far?
17, sir.
So 16.
16.
Yes,
16.
sir.
Okay. So I will check the attendance later in the systems. Any question? If there is no question, I'm going to stop the lecture.
No.
Boleh stop.
sir.
Boleh stop. So siapa yang dah tidur tu bangun-bangun lah.
Tak, sir.
Tak ada orang tidur je.
Tak ada orang tidur lah, sir.
Ada yang tinggal the apa ni, just on the MS Team je, lepas tu tinggal pergi entah merata-rata ke mana ni.
Duduk
Tak,
tu,
sir.
sir.
Sir kena snooze.
Tak ada je. Mana ada je.
So okay. If there is no question, so basically you submit those 2 questions for quiz number 3. Right?
Okay,
For quiz number 3, those carry marks, submit by tomorrow. Tomorrow means that before 12, before before 0001, before 0001 tonight.
Tonight?
Tomorrow.
Tomorrow, sir.
Tomorrow. Okay. Before 12 tengah malam apa ni lah. Before 12 tengah malam 13 hari bulan. Sebelum masuk 14 hari bulan
Okay, sir.
Okay. So thank you. If there is no other question.
Sir, pasal test. Gila
Test. Test nanti saya buat soalan.
Okay, sir.
So basically I have to discuss with Dr. Azizi dulu macam mana nak buat apa ni test. So since we are not going to, you are in year 1, right? Year 1, most probably that you only come back to the campus December ke?
Oh?
December?
December? Tak tahu saya. Tak tahu.
December?
Tak tahu.
Sir, why?
Lama benar.
Tak
Why,
tahu.
sir?
Sebab dia
Serius lah, sir.
Dia drag lagi ke, sir?
Tak tahu apa ni, tengok apa ni lah, tunggu dia orang punya official apa ni lah, official announcement. Official announcement.
Memang December, sir.
Jumpa
Saya tak
tahun
tahu.
depan, sir.
Saya tak tahu. cuma be prepared lah. Be prepared to be all the lectures are all online like this, and the test will be online test. Be prepared. So jangan main-main. Okay?
Alright, sir.
Okay, jangan main-main. So don't make sure that you study on your own. Learn to be independent. Learn to be independent. Don't just depending on the lecturers. So basically that you have to read on your own. We can only give you certain lectures just like this. And there are certain things that we cannot do online compared to the ones that if we do a face-to-face lecture. So at least you'll be able to understand some of the materials that I presented today.
Okay, sir.
And thank you and see
you, sir.
you on Thursday. Okay,
Yes.
Assalamualaikum.
Waalaikumsalam. Bye, sir.
You are all
Bye,
dismissed.
sir.
Thank you, sir. Bye, sir.
Thank you,
Okay,
sir.
sir.
Jumpa tahun depan, geng.
Woi, belum jadi.
Jumpa
Junior
tahun
lah.
depan,
Sabar,
geng.
Jadi. Sabar. Record dulu.
Sabar je ni, sabar.
Dari kerja apa, oi? Oi.
Ikut lagi ni.
Recording tak stop ni.
Macam mana nak stop ni?
Tahu?
Sebelum stop. Saya kena stop kan.
Keluar lah, Kak. Bye.
Bye.
Okay lah, bye.
Jumpa tahun depan, geng.
Okay.